So hello everyone, in this video we'll be solving another LeetCode problem, and the problem name is remove nodes from linked list. So you are given the head of the linked list, remove every node which has a node with greater value anywhere to the right side of it. In the end, return the head of the modified linked list. So what the question is saying that let's say if you are given some nodes, so let us see this first example. So you are given nodes 5, 2, 13, 3 and 8. So whenever you encounter a scenario where the current node is smaller than the next node, so remove all the nodes previous to it which are like lesser than this particular value 13. So in this case, if you see 5's next is 2, so 2 is lesser than 5, so no problem, we can move forward. So now we have 2, so 2's next is 13, so 13 is larger than 2, so you will remove 2, then you get the value 5. 5 is also lesser than 13, so you will remove 5. Now you will move next. 13's next value is 3, so you are like good to go. When you come at 3, this node value with 3, the next element is 8, so 8 is greater than 3, so you need to remove 3. Then you encounter 13 again, so 13 is greater than this particular 8 value, so you are good to go. In the end, we don't have any elements in the linked list, so final linked list look like this: 13 and 8. So you observe something, the final linked list should be in decreasing order because we are just maintaining the monotonic character. And if we want to maintain the monotonic character, so what would be the approach? What would be the approach? We can make a stack, or we can rather maintain a monotonic stack in order to solve this question. So yes, this is the main idea behind this problem. We'll be using monotonic stack, and with the help of monotonic stack we'll be solving the entire problem. Now in this linked list kind of question, I like to dry run on the example test case in order to make you understand the entire approach. So we will understand this entire approach with the help of monotonic stack, how we'll be getting to this solution, because in linked list kind of question it is just the implementation, nothing else. So I'll dry run the entire logic behind this first example, then you will be able to understand how the solution is gonna work. So let us see this first example and dry run our solution on it. So let me just create the linked list again. So sorry for that. Yes. So the values are 5, 2, 13, 3, 8. So let me just draw the linked list again. So yeah, 5, 2, 13, 3 and the last value is 8. So we'll be keeping the monotonic stack like this. So currently the stack is empty. We'll be moving with the current pointer. Obviously this will be the head of the linked list. Now we will check whether the stack's top element is lesser than this current node value or not. In this case, currently we don't have anything inside the stack, so we'll just push this 5 value inside our stack, then we'll move forward. Now our current is here 2, so we'll check whether the stack's top value is lesser than this current value or not. So 5 and 2, this is the stack top value and this is the current value, so 5 is greater than 2, so no need to worry about that, we can push this 2 inside our stack. Now we come here at 13. Now we will again check the stack top value and the current value. Current value is 13, which is greater than this stack top value, so that means the previous value was lesser than this current value. So that means we need to remove the previous value, and we not only need to remove the previous value, we need to remove all the previous values which are lesser than this value 13. So we have this top element as 2, so we will remove this from our stack. Then we have the top element as 5, so we will remove this from our stack. And currently there is nothing inside our stack, so we can just put this 13 inside our stack and move forward. Then we have this value current at 3. We will again check stack top element is 13 and the current value is 3. So 3 is like lesser than this value 13, so we are good to go. We can just push this 3 inside our stack and move forward. Now the current value is 8 and the stack top element is 3. So current is 8. That means 8 is greater than 3. That means you need to remove 3 and all the previous values which are lesser than 8. So you come across 3, that is stack top element, and you remove this from our stack. Then you come across 13, which is the stack top element, and you check whether 8 is greater than 13 or not. So no, it is not greater than 13. So you keep it as it is. then you push 8 inside a stack and move forward. Currently our current will be pointing to null, that means we headed to the end of the linked list, so we will stop our iteration here. So let me just draw what the final stack would look like. So our final stack is looking like this: value 13 and value 8. And if you remember, the final result was like this: 13 and 8. So you can see that this particular stack is currently in the reverse order. So no worries, we can take another stack and we can just reverse this order by pushing these two elements inside this stack. So we'll be taking a new stack just to take the reverse order of the current stack orientation. So first we'll pop out this particular 8 and we'll push it inside our new stack. Then we will pop these 13 from our previous stack and we will push inside the new stack. Now we have this value or the orientation like this: 13 and 8. You can see 13 and 8. Now the only thing that we need to worry about is that we need to create a linked list for this 13 and 8 and just connect them and return this 13 as the new head of the linked list. In the end we need to return the new head, but how will we do that? So let us see now. So the new stack is currently looking like this. The top value is 13 and the last value here is 8. So what we need to do now, we just need to create the nodes of these values and just connect them like this. So first of all, what is the most important thing in the linked list? The head of the linked list. So we will be creating the new head of the linked list. So what we can do, we can create a new head of the linked list which the value will be nothing but the stack top value. So new head will be nothing but stack top value, and this stack is the new stack actually. So yeah, you can just imagine like that. So stack value, the stack top value will be the new head of our linked list, and we can keep the current pointer as to the new head so as to iterate over this new linked list or the modified linked list. So current will be equal to new head, and in the end we can just pop this 13 out from the stack. So st dot pop. So now we have this value 8. So now we can just run a while loop, because in this case there are only 2 elements, but we can have many elements like this also, like 13, 12, 11, 10, 9, so on and so forth. So we need to run a while loop until this stack becomes empty. So yeah, we can just run a while loop, and what we can do, for each of the value we will create a new node. So new node, or new list node rather, new list node of the stack top value st.top, and this new node will be nothing but current's next pointer. So we have the current as the like head of the linked list currently. So this is the new head of the linked list, new head, and current is also here. So this stack top value that is currently 8, this will be the current's next value right now. So we can directly equate it to like this: current's next equal to new head of the new list node with the stack top value. So we have created the value 8, and this will be nothing but current's next value. So current is this 13, current's next is this 8. So we can just pop this stack top element now out from the stack. Now what we need to do, we just need to move our current also one step ahead. Current equal to current next. So now our current will be pointing to 8. So we will do the same thing again. So let's say the next value we have is 7. In this case the answer is over, but let's say the next value is 7. So now we will first create this value 7 with this part. We will like point this current's next value to 7 with this part. So current's next equal to 7, so 7. Then we will pop this element out from the stack and we will move our current pointer here. So this is how this process will be done. So I hope you understand this explanation part. So let us directly see the code now so that we can understand in more better way, because this was the explanation and the rest, everything inside the code is just the implementation of what I just explained it to you. So let us see the code now. So initially I have made the current node equals to the head of the linked list, and I created this stack. Now this stack will be actually in the reverse order, but yeah, for now we have just created this stack so as to maintain the monotonic order. So while current, that means while current is not null, that means until the linked list is there, we are not at the end of the linked list, so we will be doing the process again and again. If there are some elements inside the stack, and we will check whether the top element is lesser than the current value. So let's say the stack top element is 3 and the current element is 13. So this is obviously lesser than this, that means we need to remove all the values previous to it which are lesser than 13. So while stack is not empty, we'll be just popping those elements out whose value is lesser than this current value. In the end, we'll be just pushing this particular 13 value or whatever the current value is into our stack and just move forward with our current value. So in the end, after this particular iteration, we'll be having like stack in this form 7, 10, 11, anything like this, but this will be actually in the reverse order. So to reverse this particular reverse order, we will just take another stack, because stack just reverses the thing. So we will take another stack which will be just which will just give us the reverse of the current orientation. So we will take another stack and we will just push all those elements in order into this new stack. So our new stack would look something like this: 12, 11, 10 and 7. So this is this part what we are doing here. Now we just need to create these as linked lists node and just connect each and every one to it, or rather I would say like this. Yeah. So first we'll be like getting the new head of the linked list. So new head will be the stack top element. In this case it is 12. So we are creating the new head with the stack top element and we are naming it as new head. So this will be new head of the linked list, and we are just popping this element out from the stack, and we are also taking the current pointer so as to iterate over this current new modified linked list. And we are doing the same process again, creating the node, pointing the currents next to this particular node and then moving forward. So since there can be many elements, so we are just using the while loop. So currents next will be nothing but the new node that we are creating. In this case it is 11, and yeah, we are just pointing it to the new node that we created 11, and then we are popping it out and we are moving our current pointer ahead. Again we'll be taking the stack top element from the stack, we'll create a node for it, we'll marking the currents next pointer to that, we'll be popping this particular element out, we'll be moving the current pointer ahead, and so on and so forth. It will be done until our this entire stack becomes empty. In the end we'll be just returning the new head of the linked list. So our final linked list would look something like this: 12, 11, 10, 7, like this, and this will 12 will be the new head of the linked list. So you can see it is in decreasing order. So yeah, this was it about this particular problem. So I hope you learned from this solution. Thank you for watching.